good to go. No. Okay, I'm going to talk about the Open Build Server. Open Build Server is a technology that was developed by SUSE. A little bit of history behind it. I put the 3 emails up just to kind of show you my affiliation, a little bit about me. I work for SUSE as a sales engineer in Silicon Valley. I've been there almost not shy of 3 years. I've been a long-time member of the OpenSUSE community, and the Open Build Server is what got me interested in OpenSUSE. And I've been an OpenSUSE board member. I'm a founder of Apache BigTop, which is the packaging integration deployment framework for Apache Hadoop, which gets consumed by the Apache distributors. It's made up of folks that come from Hortonworks and Cloudera and a few others and some other independent projects. I've been a packager and contributor for many open source applications for a long time, and I'm an HPC Big Iron big data fan. That means my background prior to SUSE and Cloudera, I worked at Cloudera before it came to SUSE. At Cloudera, I was part of what we call the kitchen team. And at Cloudera, we started a kitchen team with the idea of setting up a build service to be able to build the whole Hadoop stack, which is a pretty complex job. And part of the premise I'll talk about today is that at Cloudera, we said, okay, somebody had published a paper and said, if you need a kitchen team that can create their own build server, some sort of build programming, and what you find is most of them are awful. And part of the problem is, that build servers or build farms or whatever are written by somebody inside some sort of DevOps environment. The problem is most of them are really awful. They're poorly documented. You have the bus factor, means the guy that wrote it and decides, I'm going to go off to another company. And the poor guys that inherit it really have their hands full. It's written in language flavor of the day, and most of them are pretty awful because they're not built around some concepts which are important for a build server, for packaging, from a security standpoint, from a reproducibility standpoint, and ensuring a clean environment for your build environment. And in particular, I pick on Maven as an example of a really good idea, horribly executed, in the sense of, it's great at solving dependencies, but from a security standpoint, it's a nightmare. The fact that even Maven repositories don't even get downloaded on HTTPS is alone, to me, a very, very bad idea. So what is OBS? It's a complete integrated package building service with its goals of reliable, scalable, repeatable, and that's really important for all Linux distributions and architectures. And you can even build Windows binaries on it by abusing RPM. There's no reason why I couldn't support BSD distributions as well as Mac OS. So being nice folks that SUSE engineers are, we don't just support our own. We support CentOS, we support Debian, Fedora, Mandriva, OpenSUSE, RHEL, Scientific Linux, SUSE Enterprise, Ubuntu, Debian, Arch even. And that kind of shows you its flexibility and so its power. And the other cool part is it saves a lot of time. It's a huge win to be able to take one source package and one RPM spec file, which is basically a make file to create an RPM, push a button, and then build on all kinds of architectures on all those other distributions with a couple of clicks of buttons. The pitch time is SUSE has something called SUSE Studio, which is free, which builds images. And so you can create your own custom ISO. So you create your custom packages, how you like them in OBS, and then import them into SUSE Studio, and you've got your own custom-baked ISO, or USB key, or VMware disk image, or bootable live in, whatever. And SUSE Manager is a tool that you use to manage all that stuff once you get it loaded. It builds it RPM debs and other package formats in a repeatable, consistent manner. Sorry for my voice. This is the 4th event I've done talks at this week. in 3 cities. It supports multiple architectures from ARM5 and ARM7, x86, all the power platforms, PPC 32 and 64-bit, Spark 32 and 64-bit, and System Z S390, which is mainframe. And it has a maintenance model, which I'll show a little bit about. And once you build the packages, it actually tests to see if they're usable. It actually does a fake root install, and it also includes a buffer flow checking, and it flags compiler warnings and permissions and file locations. So it won't let you do naughty things. How does it work? It's got sandbox builds, and you can use KVM or Zen on a build farm. It has the ability to take a given package come from some other repository, branch it, make your change, and then resubmit your changes to your branch where you branched from. It has built-in revision tracking. It's hugely scalable. The public OBS has 200,000 plus packages with 30,000 users in 32,000 projects. On average, it builds about 50,000 packages a day. To give you an idea, it can build the entire OpenSUSE, rebuild the entire OpenSUSE build distribution in a matter of hours. And in fact, that's enabled something that's called OpenQA, which warrants a whole nother discussion. It's extensible. It's very easy to add new architectures or platforms. It has an open API, and this is an old slide. It can be used with Hermes, but actually now the build server has its own built-in mailing system to do messaging and notifications. That's the part that's really cool, is the consistent, reproducible builds. In fact, as a part of its internal scheduler, it does an MD5 sum check to see if it needs to rebuild a package or not. The user interface is a REST app API, so you can run it in the web and the GUI at the same time. The web UI, which I'll show you, it's great to get an overview of a project for making simple package fixes. And then there's a command line client called OSC. It works sort of like SVN or Git, has many of those kinds of features, and you can actually do a local build on a local machine for testing. The user interface comes up on a simple web browser, and this is the UI. Most of OSC is written in Python and actually has a plugin architecture, so that there's a couple of plugins like I use as part of OpenSUSE. It's one called OpenSUSE Contrib, and one for the GNOME packages inside the build service, so that it makes collaboration on certain projects easier. The other part that's really cool is how you leverage the interconnect. And basically, you don't have to rebuild the wheel or rebuild the internet for that matter. You access the sources and binaries of a remote OBS instance, and most people use the public, it's called API OpenSUSE.org. You don't have to rebuild all those things. You can use different architectures and distributions, and if you have OBS on site behind your firewall, that way you can keep proprietary bits behind the firewall. And the remote instance is mounted in a public space, and the source and binary packages are cached, and the automatic merging and rebuilds also work with remote data. So for example, if I have cached or linked to a package on the public OBS, and I'm at my corporate OBS, an OBS rebuild on the remote one automatically will trigger a local rebuild. So you have perfect consistent binary, you have perfectly consistent dependency resolution. And so, for example, if you change glibc, every package that depends on glibc is automatically built. There's nothing manual, it's all automatic. Build.opensuse.org, which I'll show you, has about 90 connections from different remote instances. That's what we know. There's probably now over 125 folks that are running their own local OBS. Basically, for example, if you go to Dell, linux.dell.com, and you download drivers for Dell's hardware, all of that's built on OBS. They have their own private OBS, and they build every package for all the Linux distributions on OBS. So that's one of the ways you can leverage it. Well, how does it work? It's really, really easy. You create a project, you upload the sources, a tarball, some desktop files, patches, the spec file or a DSC if you're using Debian packaging. Select the repositories you want to build, which architectures, you push a button, and off it goes. It's organized in the sense of what we call projects. And projects are like a set of packages with sources. And projects feed into the main distribution. So, for example, if you folks are familiar with Red Hat, SUSE has a concept called factory or tumbleweed. And basically, all those develop projects feed into what we call factory. Factory's like the tip point of what's new in OpenSUSE, which then becomes upstream for SUSE Enterprise. So as we see here on the left, you've got OpenSUSE Factory and Fedora 15, and just as a simple example. And you want to talk about these three packages. So what happens is you do your work here, then you push them back into those standard repositories. You build off the ones on the right, and then afterwards, you push it back up. You can also collaborate and branch, and there's two kinds of branching formats. One's called mbranch, which is how we maintain OpenSUSE and SUSE Enterprise. And basically, it's a special flavor of branching that says make this a maintenance patch or a maintenance package that, for example, if you get an updated kernel or whatever, that's how it's done. The other type is a straight branch, is where you pull the packages from a given develop project, make the changes you want to see, or the updates, or what have you. Then when you're done, you merge the request. It's called SRs, submit request. And the maintainer of the upstream project gets an email and says, oh, by the way, such and such just sent you an update. And you look at it, and you can accept it, reject it, or comment on it. And that's kind of how it works. That's the workflow. So now it's showtime. Where's my web browser? And there we are. Now, for a long time, for some strange reason, I got nicknamed Mr. Docs Stuck. And when OBS became public in 2006, I was one of the first guys to raise my hand and say, I want to crack at this. And the reason I wanted it is because I was developer of Scribus, and I was the packager and release manager. And I said, oh, this looks really cool. Let me give this a whir. So back in the 1.3 versions of Scribus, we actually used OBS to do the packaging instead of me building stuff on RPMs. And it was awesome. And I wrote a blog about it called Push Button Packaging. And it was the first time I was able to support, for example, RHEL and SUSE Enterprise in our Scribus releases. So this is my home page, and let me find the mouse. And you can see that I'm involved in projects. And they're all different kinds. And if over here, these are what we call core projects. They're top-level ones, graphics, because I happen to be a graphics developer. I've been in pre-press for a long time. And then you see branches. And what I do with these branches is I may want these branches to do fixes or upstreams that submit upstream. And every individual user has a home project. That's your own sandbox. That's where you then do the work, submit into the top-level projects, and then ship eventually into OpenSUSE Factory. Now, like here's KDF. What's KDF mean? In SUSE, OpenSUSE lingo, that means KDE Distro Factory. And that means the latest packages for KDE that go into Factory. So right now, KDF, for example, would have Plasma 5. And some of these are sub-projects that I built. For example, I built protobuf RPMs and Debian packages because at Cloudera, we needed those in Apache BigTop. Those protobuf packages, which is a serialization library built by Google, were not available in the main distros. So by building them and providing them on OBS, we then could import them into all the Hadoop distributions, because they could build then, in their own build service, the full Hadoop stack. So now we've got all these. This is my incoming requests. You can see these are all different kinds of requests, and these are for project requests. Like, okay, because I maintain graphics, somebody sent me a request, and I can go look at that. If I can slide a little bit. And this is the maintenance tiering model. Certain people get packages, Okay, so now it's an upgrade. It's got some changes. You can see it's like a diff. I can review it, look it over, and say, okay, yeah, this is good, blah, blah, blah. I can send a comment, or I can decline it. Now, in this case, I'm probably going to decline it because the change log does not have sufficient changes. It doesn't tell me what the changes are to the sources, because that way, when you look at when you're end user, and you open up a package, you can say, oh, well, I just got a new version, but what's in it? We want the major changes put in this changes log. So if we go back a notch, look at my incoming requests. Now, why do I have all of these requests? You can see, because I'm a factory maintainer, and I'm part of the factory review team. So what that means is all of the development projects that get fed into OpenSUSE Factory, there's somebody that's got to actually look at with human eyeballs and say, yeah, this will pass muster. Usually it's already had one or two pairs of eyes on it, but I'm part of a team that looks at these and says, oh, okay. Now, we don't have one here, but for example, like when a security fix comes out, it won't say a submit, it'll say maintenance, and it'll say the severity. So, for example, when Shell Shock came out, when we looked at it, I mean, that was reviewed and pushed into factory in a matter of minutes. And then here, these are my outgoing requests. I can add roles, I can ask people to delete packages, and these are ones that I've been declined because I told some guy to delete. He was building an entire Linux distro in his home repository, which basically had no changes. And I said, you've got 5,000 packages in a home factory, in a home repository. That's not really copacetic. That's not cool. And the other thing is we don't allow anything that's non-GPL, non-open source inside OpenSUSE build server. So how do we deal with things like multimedia codecs and stuff like that? Well, there's a third-party repository called Pacman, which I could dive in and show you. But more importantly, I think just to give you the overall, this is where the maintenance model comes in. So these are probably changes that Stephen Naukulo, he's the actual release manager for SUSE, OpenSUSE Factory. Now, because I know he's a pretty sharp guy, he wouldn't send changes unless it was something simple or, okay, now he's made some changes, blah, blah, blah. Okay, he's cleaned up the package a lot, Ooh, got rid of a lot of tarballs, cleaned it up, and it's a meta package. So now, this is a new way of packaging text live, which, as you know, was broken up into a bajillion little packages. That's a big change. Now, that one I probably wouldn't accept right away without probably a few minutes of looking at it. No, I'm not going to do that. So that one there is going to wait till I'm home. Now, this one's been sitting around for a while because we don't need it, but the guy never rescinded his request. Now, these are going into repositories. Now, here, for example, let's find something simple. Test all tray. Okay, I'm going to look at that. Initial release. So it's a new package. So I would probably say no to that here, but let me look at something simple that I could trust. I could just kind of push a button on. And let's see. Oh yeah, let's see. So now, there's a submit request. We looked at the changes and all that sort of thing, but we also looked over here. It's unresolvable. Why is that unresolvable? Because it shows you right there what's missing. So if I go look here, I look at this, we click that. Yeah, you can. Yeah, what happens then is you get a merge conflict, and we have a neat trick to fix that. It's called OSC pull, and that is a tool that allows you to fix the merge clashes. Like when it'll show you a diff that says, oh, these don't. It's like a patch or a diff that won't apply. So you use a tool called OSC pull those in, merge the changes properly, and then resubmit it. So yeah, you can resend a green light. I have done it because you realize, oh, that change really broke something. We need to pull it, rescind it. So now we clicked on that build link, and what we did here is actually look at the link. And this is where it's really cool that it shows you exactly what's going on in the build route. Every package build has a route, has a very detailed log. So if we look at it here, it actually kicks off a KVM, and that means it's a brand new fresh install of OpenSUSE Factory. And when I was talking about how you have a consistent, repeatable build environment, that's part of it. So basically, when you kick off a package build, you're creating a new KVM instance, freshly installed, with only the dependencies that are required to build, that are explicitly declared in your RPM spec file or your Debian control file. So it shows you it's installing the packages, it's doing this, it's doing that, it's updating this. Now it's installing the packages, and you can see what's going on, more, blah, blah, blah. This is the cool part. It starts here. All right, it gives you the build command utilities, and it walks through the build step by step, so you can see what's going on. So if the build fails, it's easy to diagnose. Now it built it. All right, now what it's doing is it's going to actually test building a test install. And after it does that, it runs a whole pile of checks here. And these are all written in RPM, written in Python, and it's called RPM lint. And they're all customized. Like, for example, we make sure that there's no LA files, because we don't want static binaries. So now we've got an RPM lint report. Okay, well, this file's marked improperly. And the RPM lint warnings have a concept of badness. So certain things which are evil get a score. And if the badness score exceeds 1,000, the package is considered failed, even if it builds, even if it compiles, even if it installs. So that's part of the testing. And then it shows you the changes, and it kills it. And it can generate debug info as well. So you can see every single step of the way, you know what's going on, installs it, prepares it, blah, blah, blah. That's the really cool part. And these checks actually fix and catch a lot of errors in packages. Almost no package comes through without 0 warnings. They're rare, or they're very simple packages. As I said before, it checks permissions. It checks for invalid requires, so you don't pull stuff in you don't need. All things like that.
I might have missed it, but how do you differentiate the architecture for a build? So, x86 works and x86 fails, or
That's pretty simple.
is it all the same long log file, or do you have?
No, each build on each arch has its own build log. So, for example, that's the web UI, and just shows you the down. I showed you the whole full log before. Okay. I probably didn't see where we are at the arches. Those are the different arches that are available to build on. Now, for example, if I go here, let's go back to my home. Let's go to my home project, my sandbox, because I can show you a lot there. I love small resolution screens for this stuff. I'm going to go to my home project. This is my sandbox. Okay, so if I look here, I've got 31 packages I maintain. And some of them are maintained further upstream where I actually maintain them in OpenSUSE, and SUSE Enterprise for that matter. So if we look at repositories, okay, these are all the distros I built for, which is quite a lot. And then we look at the architectures. I try and build for everything. Now, the public build server does not enable building for mainframe, and that's because of a long-standing agreement with IBM and SUSE, because basically IBM is very protective of what goes on a mainframe, and they didn't want unsupported packages going on a mainframe, which is sound because I have mainframe customers as a sales engineer, and I can tell you those guys are the most conservative bunch you could imagine. but that's why they stay up for years at a time. And if you have major banks that I know in a couple of cases, our customers are major banks where they're running their entire ATM network on System Z hardware and SUSE Linux that maintains our ATMs. You don't want any kind of uncertified software on a mainframe in that kind of environment. And you're lucky to be a customer of these companies, these banks that run the ATM network on a mainframe because they're bulletproof, they're disaster proof. Yes, this was actually architected. Most of this was built in house, and it actually is like version 2 of the original SUSE Enterprise build system called AutoBuild. And they took AutoBuild and said, think of all the pain points, and then try and build something new that's more flexible and more powerful. And the guy that wrote a good chunk of the OBS is a pretty sharp guy. His name is Michael Schroeder. He won a national pro coding contest in Germany when he was like 15. And anybody know what Delta RPM is? You Red Hat guys will know it as Presto. He's the guy that invented Delta RPM. And he also wrote the library called libsatsolve, which solves dependencies according to some fancy algorithm generated at MIT. He's the guy that wrote libsatsolve, which now actually Red Hat uses as well as SUSE. SLES has had that for a long OpenSUSE and SLES have had it for a long time. I think they put SatSolve in Red Hat 6, I believe. So, questions? In the back. A very good question. No, well, yeah. Yes, there is. We call it. I'd be glad to show you how we handle that because that's the. Let me see if I can see that. I could show you very easily. Come on. This is a package. This is my own. We look at the changes file, spec file. Okay. You're going to see how I if-def dependencies. So this is for Fedora. So I have all the correct names because there's slight variances in some of the package names which actually provide the same bits. Why, I don't know, but it's just some of its history. So for example, that's for Fedora. And if you're newer than 14, it needs this. So you can use endifs and ifdefs. And these macros are understood by OBS. So you can see I can even specify specific versions, equal or greater to. And then even Mandriva and SUSE, and then, okay, a special version, an older version, if it's newer, blah, blah, blah. And then the requires, and then even in some of the exporters paths, you can if-def all kinds of build conditions according to the distro. It gets turned, well, as it reads that spec file, RPM build actually reads that spec file and evaluates the conditions, if yes, if no. It basically it evaluates to 0 or 1. So that's how it works. And of course, your RPMs, macros and things like that. So with one spec file and one tarball, I built it for about half a dozen RPM distros, and I could more if I wanted to enable them. But, I don't think Scientific Linux really cares about desktop publishing. So why waste the build server's power? Why waste power on the build server? Sure. Yeah. Oh, good question. There actually is an RPM template spec generator in OBS. So if you create an empty project, it'll create you a skeleton RPM spec file. And the easiest way to learn RPM packaging is to borrow somebody else's package and read how it works. Make sure you get a good package, relatively simple. I prefer like a C or C++ binary that's command line. Grab that, learn how that spec file works, and then you can start trying playing with other packages. And the power of the build server is that it allows you to experiment with those kinds of things very easily. So you see all kinds of weird branches. I've even seen branches of branches. And why is that? Because somebody will be working on a package trying to fix something, and they'll run into a problem, and they'll go on IRC. And I've done this. I've branched somebody's branch to help them fix a problem, submit it to them, then they submit it into the project. So you can do those kinds of crazy things. Question? Oh, yeah, it's a complete, like a branch is like its own little mini project. And what you do oftentimes is when you do a SR and you submit it upstream, you can say, I want to keep that branch and keep it aligned to the changes in that upper project, or I can say delete it. Oftentimes, I'll create a branch, make a change, submit it upstream, and I'll delete it. Question in the back. No, it supports Debian. It fully supports all the supported versions of Ubuntu and Debian. And in fact, an example, there's a company called Viata, which is a software-defined networking company. They were bought by Brocade, and they use OBS to build their entire SDN appliance, and it's all Ubuntu-based. I think it eventually will get moved to SUSE Enterprise because they want enterprise certifications and things like that. But the ability for them to transform from a Debian platform to a SUSE platform makes it trivial.
In terms of setting up the whole system,
Mm-hmm.
like is it like more or less complicated than say setting up Koji? Is it relatively straightforward, or is it pretty?
No, it's pretty straightforward. The biggest weakness is some of the documentation and how to get it up and running. I actually tried to port Koji to SUSE. Just to give it a whir, because what I found was that there were too many Red Hat specific code paths. You can actually run OBS on CentOS. We've had people that actually ported all of the OBS infrastructure to CentOS because it's all GPL code. And what the OBS team does is they provide appliances that are pretty straightforward to install. They're VMware instances or KVMs or whatever. That said, that's great for experimenting. But if you're going to run a real OBS, you want to put it on bare metal. And the reason being is you've already got one level of nested virtualization. And as we who are familiar with the build server, we joke that OBS is one of the best torture testers for hardware on the planet, because you've got compilers running, you've got virtualization, lots of I/O, lots of memory, and you'd be amazed how many machines get blown up at SUSE in Nuremberg because of the stress. And I was just saying before we got here early, OBS, the public OBS, is broken, I mean majorly broken, a SAN system, not once, twice. How hard is it to break a SAN? You got to really try. You got to do something. You got to really try to break a SAN. Question.
I have two questions. Actually, I am in need of a library package that's available on CentOS 7.
Mm-hmm.
That's not available on CentOS 6.
Dead easy to do. So what you do is you create a home project, and then you enable CentOS 7, and then you enable the CentOS 6, and say build that particular package. As long as the dependencies are available in CentOS 6, and it doesn't have specific versioning, it should be pretty trivial to be able to do that. I've done that a ton. I did a lot of that at Cloudera. Like, we wanted a common version of Puppet across all the platforms that we supported at Cloudera. So that meant RHEL 5, 6, back then, SUSE Enterprise, and Ubuntu. So we're using OBS. I was able to build a common, exact same version of Puppet for all of the architectures and all of the distributions. And it was pretty easy.
Can we install open source server in our company environment locally?
Yes. Yes, you can. In fact, in the slides before, I showed you there's like over 100 companies that interconnect. Let me switch gears. I'll show you. Come on. This is in the appendix, and I'll have this uploaded. That gives you an idea who uses it. For example, SGI uses that to build all their internal packages. Dell, like I said, linux.dell.com. Open source communities, Mare, and even Sailfish, the phone OS, that's built on OBS. Open Exchange. Microsoft even uses it. When I was in France, I worked for a lab called INRIA, which is the French Computer Research Lab, and I was a project manager for a big distributed computing project called Extreme OS. And originally, it was built only on Mandriva because, as it was an EU-funded project, it only could be operated by an EU company. So Mandriva, by default, was the distribution that got the call to support this underlying project. But the wish was to be able to support OpenSUSE and Fedora and RHEL and SUSE. So I set up an in-house build service at INRIA. And when you're in a computer research lab like that, if you've ever worked in one like that, you know that resources are pretty easy. You know, you go down to the workshop and say, I need 6 laptops to test it. And they go, give you a tray, and away you go. So at our lab, we were part of a big grid project called Grid 5000, which means we had racks and racks and racks of servers, which got upgraded every 18 months because it was, the idea of Grid 5000 was 5,000 cores available for the whole French Computer Research Institute. So I got some hand-me-down servers, which were actually not too bad, considering they were 8-way Dells, and then I took and cannibalized them. I put 2 disks in each, swapped the memory in, so I had nice beefy machines, and I had a half rack just built just for OBS internally. And the reason I needed that was the project created some 1,400 package dependencies, most of it Java. So the only way that I would be able to port 1,400 packages specific from Mandriva into OpenSUSE and CentOS was build server, and we did it. It took 18 months, but we were able to. And if you know anything about packaging and Java, the dependencies are hell, because what happens, Java developers, some, have a particularly bad habit of taking a library, putting their own tweaks, and then bundling it into jars. And then when you try and compile it, like, why does this break? Some. Yeah, somebody's clapping. Some. I know some good Java coders as well. A lot of the Hadoop guys are pretty clever. And yeah, so yes, you can host your own one, but be prepared to have some infrastructure in terms of hardware. The minimum I would have as a build server is 2 physical blades and 8 gigs on each, and a lot of disk space, because you need 300-400 gigs of space because you're downloading all the repositories, all the updates and deltas. Plus, you need a build environment, et cetera, et cetera. That said, you don't have to reinvent the wheel, so use the interconnect, and that's how Pacman works. Pacman is the largest third-party packager for all of OpenSUSE and SLES, and that's where you get VLC and all the patent-encumbered stuff that you can't include in the public build server. I saw another hand in the back. Question? Go ahead. Yes. Oh, yes. Yep. Dell, Linux.dell.com basically is that's the repository that Dell uses to build all their driver packages for all the Linux distributions, Debian and Red Hat and SUSE and OpenSUSE and the lot. All those packages are built on an instance. They actually have 2 pretty good-sized ones behind the firewall at Dell. And Intel uses it for a lot of their internal R&D stuff because they actually do a lot of packaging in-house. And one of the things that Intel added as a contribution, because it's an open source project, Intel added the LDAP authentication to the build server. So you can use LDAP. In theory, you could use Active Directory, but I'm gluing that together. I've done that kind of stuff, but it's not for the faint of heart. And you almost have to like and be as much of a Windows guru as a Linux guru. So we've got, how much time do we have left? We got, 20 minutes? These talks tend to go fast or slow depending on questions and things like that. Now, let me switch back to the browser because that's more interesting. Sorry, I went too far. No. Let's hit escape. There we are. Okay. So there you have a really robust, integrated solution to packaging. Oh, there's some other things I could show you, which really are important as well. Because not only does it do the packaging, let's go and look at the monitor. Let's look at the monitor, because that's pretty cool too. It shows you what's going on. So you can see the server status, and all these things, green lights. So you can see here, we're building everything in the back home, backstage, back main, and workers. Workers are the actual systems that do the builds. So you can see we got quite a few builders. There's like 500 builders. And you can actually see here how many packages are waiting to build and are blocked. So what's a blocked package? If I'm rebuilding libc++, glibc++, there's going to be hundreds, if not thousands, of C++ packages that are going to be blocked, because as soon as that builds, they're all going to rebuild. And that's automatic. It's not something, you can't even stop it. It's forced. And the reason it's done that is to ensure that there's perfect symbol. You never have a problem with like symbols missing or anything like that. That's the perfect repeatability of OBS. And if we go here, you'll see there's some engineers at SUSE that have a sense of humor. So you go up here and you say, oh, guess what? This page is meant to entertain and not be exact. If you need details, you go to the detail page, and then we go down here. So now you can see every single package that's cooking away. And how many workers do we have? We have packages in the blocked queue. Why is there so many packages in the blocked queue? Because right now, OpenSUSE Factory is digesting GCC 5. So you can imagine all of the rebuilds. That basically rebuilds the entire planet. And it gets a lot of breakages. And so that's why you see here and here why there's so many in the waiting queue and in the blocked queue. And you see here Arch 64 and 6, ARM 6 and 7. Those are actually built on emulators. Go ahead.
That's actually what I was just going to ask. Is do you native ARM builds or not?
Our guys actually built that for ARM because we wanted to be able to build ARM packages without having to run it on Raspberry Pis.
Well, yeah, I mean, the main thing for us in GNOME is like we run geographic inspection, which has to like link against the program and actually run some code to extract data. So like we have to run native.
Yes.
Part of the build. And like Yocto does something with like keeping system ARM for just running the binary, but not a kernel.
Yeah. No, it's a combination because we actually now have it's funny to see this stack of little ARM boxes inside the build server, and they actually do run builds. Some of the builds are native, and some of them are run in the emulators on 64-bit hardware. So you can imagine the advantage of the emulators is it speeds things up tremendously. Just a little. Just a little. And if you see here, we now, because SUSE has a really good OpenStack solution, we actually have cloud instances to torture test our OpenStack implementation. Go ahead.
So is upstream dependency break downstream package? I'm assuming the downstream package doesn't get published.
Correct. Correct. So failed builds do not get published. Let me show you that's a good question. There's another couple of parts that are really cool about OBS. Yes. Yes. Yep. There's a choice in the notification system. So why are some of these in red and some of these in yellow and some of these in green? Well, it's because what this red means is that I'm trying to build Chromium on an ARM 7, and that's probably a real ARM box. And it's taken 4 hours because it's trying to build Chromium on an ARM box. So you can imagine it takes a few hours. So if we look over here, though, these are some other cool things that I didn't talk about yet, but I will go into a little bit. Now, what the dispatcher does is it actually kicks the builds off. And the publisher is the one that actually takes the packages that have been compiled properly and built and publishes them. What it does by publishing them is it actually sets up an automatic, it pushes them into public repositories, and then they get mirrored. It goes to a server called WideHat, which is then the staging mirror for all the OpenSUSE mirrors around the world that mirror OpenSUSE packages. Not everybody mirrors all of the home repositories because there's 20-something thousand, but there is one, FDPGW, one of the German universities, mirrors all of the home repositories, all of the packages. So that's one part of it. The other part's the signer. What does a signer do? Well, one of the things to ensure package integrity is to sign them GPG. So each project has its own GPG keys automatically created and automatically signs all of the packages. So you can ensure that there's nobody's tampered with the packages if you download them off a public mirror. And you can do the same thing if you're compiling packages in-house and you want to sign them with your own corporate key. You can do that as another assurance, quality assurance, with your RPMs and Debians. And then there's this other thing called a warden, and these are all individual services that run in the back end. What does the warden do? Well, what the warden does, it keeps an eye on the builders. And if the wardens see builders acting up, it kicks them out of the build farm. So there's a lot of automation built into this. Go ahead.
Or do you want to keep your GPGs off of the machine that's connected to the internet?
Generally, most of the build server infrastructure doesn't see the internet. This web UI connects to the build servers through a firewall, or isolated from. You can't get to the build servers from the internet.
Is it possible to like drop the public or the signer system and like use your own key somewhere?
Yeah.
And like sign packages and then push them back into the publisher?
Yeah, if you wanted to sign them offline, you could do that. Yeah, that can be done. Yeah. Yeah. But generally, I mean, that's I wouldn't say it's an outlying use case, but the way that it automatically creates that sign key is pretty useful because it's easy in the packaging tools to ingest those keys. You know. The other part of OBS that I like is the warden business. I mean, you don't, if builders die, you're not going to get jobs scheduled on them. And the job scheduler actually has the ability to set priorities, and it can set priorities by project. So, for example, like I've actually gone to the OBS guys and said, I'm going to do a demo today. Put my project in make my project high priority. So I would just doing a demo with my repository set as high priority. It might block other builds until my stuff builds. But there's enough capacity running today. I see enough idle builders. I could kick off a build and it would probably be almost instantaneous. Any more questions?
What's a typical workflow once these things get built from RPMs to getting put into a repository so people can use them? And
that's what that publisher does. The publisher automatically generates the repositories, publishes them, and creates the repo MD or an index and all the app. It's called app data XML, but basically all the infrastructure so that your native packaging tools can consume them easily. So if you in SUSE world, you'd go zipper AR, add a repo, -F to refresh it, then give it the URL and then an alias. And it'll automatically set up the repository so that your packaging tools will see updates in that repository magically in a lot of refresh.
Can it host the repo too, or does it just RPM the artifact?
No, in a private instance, it actually it hosts the repo on one of the machines. In the OpenSUSE case, because it's so massive, that stages to one server that's then mirrored around the world. Any questions? Thoughts? Impressions?
We built something similar with Jenkins
I'll let you in a little secret. When I talk about this is the only sane building system, there's another one. And it's because I had a little tiny bit to do with it. It's called Apache BigTop. And Apache BigTop is a project I work on. It's all packaging, building RPMs for all the Hadoop stack. And that was something inherited while we worked at Cloudera, and that runs off of Jenkins. And in fact, you can connect Jenkins to the build server and run remote commands on the build server via Jenkins. And one of the other things, another thing I didn't show you is the concept of service files. So, for example, and this is where the DevOps side is really cool. You could do it a couple of different ways, but basically there's a method where you run, it's called OSC service run. And what OSC service run will do is, depending on the URL of the source code, it will do a git pull or an SVN up, pull all the bits in, create a tarball, create the generation of the, say for example, git tag in the spec file, and then automatically build the file. We do that with one of my Scribus packages, where we have trunk. I run OSC service run, and it automatically does that pull, creates a tarball, and does all the magic and signs it. So you can actually integrate OBS with a Git repository somewhere, or SVN, or Mercurial, or even creaky old CVS. And that's pretty cool. So that you could build cron hooks or Jenkins jobs to trigger builds on a build server, and that's all fully supported and built in. So you'll see some packages on OBS, the versioning actually has a git tag on it, a git hash. And you can also pull in RPM source files, and they'll rebuild them as well. So you can upload the raw SRPM, and it'll automatically kick off a build and run that. Any other questions? The dependencies are resolved by two ways. One's on a project configuration level, and well, I can show you. We have a file known as a project conf. Sorry, let me. Most of the dependencies are resolved by the Debian control file or the RPM spec file. But then in certain cases, you might have a choice. So what you do is you go into the project file. Let me go to my home project file, and we go into the advanced tab, project config. Okay, now you can have a prefer tag, so that if, for example, there's two versions of OpenSSL, you can say prefer OpenSSL greater than or equals 1, or you want to prefer the old version. You can do the same thing. That's one way you can declare projects. And if you see, okay, status, you can see all the things going on in one repository. It gives you a lot of info as to what's going on. And I'm very happy. It's very snappy today. Unknown build failure, okay? It'll show you stuff that's broken. I know why it's broken and just leaving it, but then we call OSC meta. This is the actual file that controls, like, for example, descriptions and the arches and all that sort of thing. Because, like, for example, when I had, this is an old one, I actually need to clean this up, OpenSUSE 11.1, I built against a specific repository that had Qt libraries. And you can see here all the different ways that these are defined. And then you can put attributes on it, which is like tags. You just add a tag. And here's subprojects. And like, for example, I could add users to a project. And then I see requests. There's none coming in. We can look at what's going on. You can see a grid, what's failed, what's not, and why. So this is a sandbox, so I expect stuff to blow up in it. And then we have the overview. So that's kind of how it works. And you can even search for packages, and then you can look at the top-level projects. Let's go to the top-level projects. You can see how it's organized. This will take a little bit. So you can see here, and then you'll see the main ones. Maintenance. This is how we do maintenance, like when we do upgrades, fixes and things like that. And these are open requests and open incidents. And then we can go back and look at factory. And in factory, we do something called, we've done something new with OpenQA, which warrants its own talk. At the mini summit, where is Marcus? Oh, he disappeared. He gave a talk on OpenQA, which is the next step of automated testing, is testing the entire distribution, automated. Every time we generate a new ISO, how do we test it without having to do human interaction? And if you go to openqa.opensuse.org, you see what OBS generates, because OBS generates not only the packages, but actually creates the ISOs, then get imported into OpenQA, and we have a whole bunch of automated tests to make sure that not only does it install, but stuff works. It'll actually test opening up the browser, opening up Thunderbird, running an SSH connection, all kinds of different tests using something what we call needles. And that's the nice part, is that now you can go from source code to a working ISO, and every step of the way you've got some automated testing included. So the human value add is actually being the eyes and ears where you really need the intelligence. It's all GPLs. All of it's GPLs. And in fact, they haven't admitted it, but I believe our friends in Red are testing OpenQA on their own distro. We didn't build it just for SUSE. And I'll show you just a little bit about the history. Started in 2005, and then now we're at this is actually wrong. We're at 2.6. And, oh, sorry, no wonder, duh. I should, nope. There we go. Oop, Let me go down. This slide deck is readily available. I think it's on the OBS, Open Build Server. I'll give you an idea. Storage, and that's some huge numbers. That's actually out of date. There's over 500 workers now. And we're at 2.6 now. And support, of course. The build server mailing list is very active. I'm on it. The main developers are really, really good about responding to problems. And the IRC on Freenode, Internet Relay Chat, Open SUSE build service is very lively. And you can get support from B1 Systems, which is a major partner of SUSE in Europe, but they've done stuff worldwide. They actually will come in and help you do an OBS implementation in-house. And we're working with another partner here in North America to be able to have full support for the Open Build Server here in North America. And so to learn more, go to openbuildservice.org. Thank you. I know you guys got tags on the badges to fill in the survey, and please do fill in the survey, and love to hear your comments and questions and all that sort of thing. And you can find me on the Open Build Server, Open SUSE Build Service channel almost all the time I have an internet connection. And thanks for coming. Sure. Sure.